Welcome to the Twin Labs podcast, where we help you make better decisions using digital twins. Today, we're diving deep into a topic that's really changing the game in artificial intelligence, building AI agents.
Yeah, it's moving fast.
It really is. We're looking at some really insightful material today, a guide that kind of pushes past the usual idea of AI just being a chatbot, you know?
Right. Not just question and answer.
Exactly. This guide explores how AI is becoming, well, genuinely autonomous, capable of thinking, acting, and actually improving itself over time.
That's the core idea. The source we're digging into, Building AI Agents, a guide to effective prompting and workflows, makes a really strong case. It argues that, yeah, the AI models themselves are getting more powerful all the time, but that's not the whole story. The real key, according to this guide, to unlocking what these things can really do isn't just having the latest, biggest model. It's all about how we steer them. The instructions, the prompts we give them. That's where the magic happens, or it doesn't.
Okay, so that sets our mission for this deep dive pretty clearly. We're going to unpack the principles behind guiding these advanced AIs effectively. We want to get a handle on how to design solid AI agents and the workflows they use to, tackle complex tasks.
And it involves some ideas that might feel a bit counterintuitive at first.
Like what?
Well, this notion that prompting is the new programming.
Right, I saw that. That definitely catches your eye.
It does. And we'll explore how things like structure, demanding real clarity, and constantly refining our instructions, that iterative process, are absolutely vital. That's how we go from a simple tool, like a basic chatbot, to something much more powerful and, importantly, reliable. An actual agent.
And this isn't just abstract theory, is it? We're talking about building AI that can plug into real business processes.
Exactly. Like the kind of complex systems that use digital twins, the kind developed by Twin Labs.
Yeah.
Understanding these prompting principles is fundamental if you want agents that can, say, pull the right data from a twin, run specific simulations, or even trigger actions based on complex logic within that digital environment.
Okay, let's start at the beginning then, the foundation. The guide defines AI agents as autonomous entities, not just text generators. What does autonomous really mean here?
It means they operate with a certain degree of independence when tackling a problem. It's not just reacting to one input.
Okay.
So unlike your basic chatbot that just gives a single response to a single query, an AI agent is designed to first think about a task. It might need to break it down, plan steps. Then it needs to act based on that thinking. And acting can mean more than just writing text. It could involve using a software tool, accessing specific information, calling an API, maybe triggering some external process.
Right.
And crucially, they're built with ways to improve, often through mechanisms like reflecting on their own performance or using feedback.
So the jump from, say, asking a chatbot, what's the weather, to having a real AI agent. It's not just about the complexity of the initial question.
No, not at all.
It's about the AI's ability to manage a whole process, something with multiple steps, remembering context, pursuing a goal over time.
Precisely. The source gives some good examples. Think about really sophisticated customer service bots, the kind that don't just answer FAQs, but can actually troubleshoot a problem, diagnose what's wrong, maybe even initiate a fix across different company systems.
Okay, that's definitely more agent-like.
Or research assistants. An agent could be tasked with finding information from, say, 10 different sources, synthesizing all that information, and then presenting it back as a structured report. That requires planning, acting, and structure of the output.
Which brings us back to that central argument you mentioned. The big shift isn't just the models getting better, but how we talk to them.
Exactly. The guide really hammers this point home.
Yeah.
Unlocking AI's power isn't about just passively getting answers. It's about actively engineering its behavior through very precise instructions. Often the difference between an AI that feels, kind of flaky and unpredictable versus one that feels incredibly capable.
Yeah.
It often just boils down to the structure, the clarity, and the refinement that went into the prompts and the workflow design around it.
So this paints a picture of the future where AI isn't just a conversation partner.
No.
It's actually doing things for you or with you.
That's the goal. Developing agents that can execute really complex workflows with a high degree of precision. They're not just chatting, they're thinking, acting, delivering actual results based on a defined objective.
That's the agent part really coming through. It's about action and purpose, not just language.
Exactly. And getting that level of performance means we need to get really good at communicating with these systems, which is why the source spends so much time on prompting techniques.
Right.
And the first big one they cover is chain of thought prompting.
Okay, chain of thought. This sounds like it's about guiding the AI's internal process, right? Getting inside its head, so to speak.
That's a good way to put it. It's a technique designed to make the AI slow down, essentially, to break down a complicated problem into smaller sequential steps.
Mm.
It's trying to mimic how humans reason through things methodically.
So instead of just firing off a question and hoping for the best.
Right. You structure the prompt to explicitly ask the AI to explain its thinking process as it goes.
Okay.
The guide uses a simple math example, like if you ask, what's 25% of 80?
Hmm.
A standard prompt might just give you the answer 20.
Yeah.
But with chain of thought, you'd prompt it differently. Something like, okay, let's think step by step here. First, what is 10% of 80? Show that calculation. Once you have that, how would you use that number to find 20% of 80? Show that step 2. And finally, how do you get from 20% to 25%? Show me each calculation along the way.
Ah, okay, so you're forcing it to lay out the intermediate steps. Why is that so much better?
Well, the analysis in the source shows it's effective because by demanding those steps, you stop the AI from just jumping to a conclusion. It prevents it from using maybe flawed shortcuts it learned during training.
Makes sense.
It forces a more deliberate, transparent line of reasoning. Think of it like asking a student to show their work on a math problem.
Right. You see how they got the answer, not just if it's right, and if it's wrong, you can see where they went off track.
Exactly. And that principle applies way beyond simple math. It's a general rule. Slowing down the AI's thought process makes it smarter. When you prompt vaguely or push for speed, the AI is much more likely to make errors or, hallucinate things.
It's a big problem.
It is. But by structuring prompts to encourage this kind of methodical thinking, you significantly boost the reliability and accuracy of the output. And that's critical for anything requiring precision coding, complex data analysis, or making high-stakes decisions, like those involved in managing systems with twin labs where data integrity is paramount.
This idea of guiding the AI's internal steps, it seems to connect directly to that other big concept the source mentioned. Prompting is the new programming. That sounds like a pretty radical shift.
It is bold, but it's becoming more and more true. Think about traditional programming. To get a computer to do something specific and complex, you had to write code. Python, Java, whatever. You needed to understand syntax, algorithms, data structures.
Yeah, the whole shebang.
Now, to get these powerful AI models and agents to perform specific, complex tasks effectively, the core skill is crafting really precise, structured instructions. In other words, prompts.
So the implication there is you don't necessarily need to be a hardcore coder anymore to build powerful AI-driven applications.
That's a big part of it. The barrier to creating sophisticated automated behavior is shifting. It's moving away from mastering complex programming languages towards mastering effective communication and instruction design for the AI.
Okay.
The source illustrates this well. They compare a really weak prompt for a coding task, like just saying, write a Python script.
Which could mean anything.
Exactly.
Yeah.
Versus a much more refined prompt.
Write a Python script. Use the request library and the beautiful soup library. I needed to scrape product titles and prices from the first page of an e-commerce category lifting URL, which I will provide, and then save the results into a CSV file named products.csv.
Wow, okay. That's night and day.
Right. The second prompt is way more descriptive. It specifies the language, the libraries, the exact data needed, the input format, the output format, even the file name.
And that level of detail completely changes what the AI gives you back.
Totally. It transforms the output from some generic, possibly useless script into something tailored and immediately usable for that specific task. The guide argues that this skill, being able to articulate requirements clearly and precisely through prompting, is becoming a fundamental literacy. Kind of like how basic programming skills became important in the past.
And that really highlights the power of getting the prompt structure right.
Absolutely.
The source makes this point really strongly. A great prompt can make even a decent AI model perform brilliantly, while a weak, sloppy prompt can make even the most advanced model seem, well, pretty useless or frustrating.
It's like having an amazing power tool, but if you don't have clear instructions for how to use it for your specific job, you're not going to get the results you want.
Yeah.
They use summarizing an article as an example. Weak prompt. Summarize this article, what do you get? Probably a generic overview, maybe just listing the points in order.
Okay.
Strong prompt. Summarize this article in exactly 3 bullet points. The target audience is a busy financial analyst. Only highlight quantitative data, potential market impacts, and any key regulatory considerations mentioned.
That's so much better. You're telling it who it's for, the exact format, and the specific content to focus on.
Precisely. You define the audience, the format constraints, the focus areas. You're directing the AI's attention, shaping its output to be maximally useful for that specific context. The underlying model's ability to understand the article is still there, but your prompt leverages that capability much, much more effectively.
It really shows the quality difference isn't just about the AI's raw intelligence.
No.
It's about how you frame the task for it.
Exactly. And that perspective changes things. It shifts the focus from just, talking at the AI to actively designing its output and its behavior.
Which leads nicely into another analogy the source uses, which I quite liked. Teaching the AI like you'd train a new junior teammate.
Yeah, that one really clicks, I think, because it applies familiar human principles of good management and training to interacting with AI.
Right. When you bring a new person onto the team, especially someone junior, you don't just throw tasks at them.
No, you give them context, lots of it, about the project, the team goals, why this task matters.
You show them examples of what good work looks like.
You might walk them through a process, step by step the first time.
And importantly, you'd probably ask them to explain their thinking, right? Like, okay, tell me how you're planning to tackle this before they dive into something critical.
Exactly. And the guide says, do the same things with AI, give it clear context, include examples of the output you want whenever you can. We'll talk more about that technique later.
Okay.
And crucially, prompt the AI in a way that encourages it to explain its reasoning or outline its approach before it gives you the final answer or takes an action.
So prompts designed with that kind of teaching mindset, they lead to better results.
Much better, much more reliable outcomes. It frames the interaction as more of a collaboration, not just issuing commands.
That idea of asking the AI to show its work or explain itself, the source actually formalizes that into a specific technique, doesn't it? The explain first, then answer method.
Yes, that's right. It's a very practical way to handle tasks that need judgment or analysis, not just spitting back a fact.
So instead of just asking, say, is this email persuasive?
Which is a simple yes-o or rating.
You structure the prompt to demand the analysis first.
Exactly. A better prompt would be something like, analyze the persuasiveness of this email. I want you to explicitly evaluate its tone, its clarity, how well it identifies the recipient's needs, and the strength of its call to action. Write down your findings for each of those points. Then, based on that detailed analysis, rate the email's overall persuasiveness on a scale of 1 to 10 and suggest some specific ways it could be improved.
Yeah, I see the difference. It forces the AI to justify its final conclusion.
Precisely. It can't just pick a rating out of thin air or give a generic suggestion. It has to demonstrate its understanding by breaking the task down according to the criteria you provided, tone, clarity, call to action, etc., before it gives that final judgment.
It acts like a built-in sanity check.
Yeah, or a validation step. It forces more critical thinking and analysis rather than just, pattern matching or making a guess.
And the source highlights this as really valuable for, anything requiring nuanced judgment.
Absolutely. Think about drafting legal clauses, evaluating marketing copy, maybe even aspects of medical diagnosis support or strategic business planning. In all those cases, you need the reasoning behind the conclusion. Explain first, then answer. Helps provide that transparency and forces a more rigorous process.
Another really fundamental principle the guide emphasizes, and this applies just as much to managing human projects as AI tasks, is breaking down big, complex problems into smaller steps.
Oh, definitely. Trying to get an AI agent to do something huge and complicated with just one single prompt. It's almost always going to fail or give you really low-quality results.
Yeah, I can imagine.
The source uses writing a full business plan as an example. If you just give the AI one prompt, write a business plan.
Good luck with that.
Right. You'll likely get something super generic, maybe filled with made-up stuff, and ultimately unusable. The task is just too big, too multifaceted for a single interaction or thought process.
So the better way is to break it down into a sequence. Create a workflow.
Exactly. First, you might prompt something like, list all the key sections and subsections that are typically required for a comprehensive business plan for a new tech startup. The AI gives you an outline.
Okay, step 1.
Then you take that outline and move to the next step. Okay, for the market analysis section you just listed, I need you to expand on that. Draft 3 specific subsections covering target market demographics, estimated market size, and key growth trends. Use publicly available data where possible.
And you just keep going like that, section by section.
You got it. Draft the competitive analysis next, then the financial projections, then the marketing strategy, and so on, building it piece by piece.
What are the benefits of doing it that way?
Well, first, it dramatically improves coherence. The AI is focusing on one smaller, specific objective at a time. Second, it significantly reduces the risk of hallucinations because you're keeping the scope of each request tight. It's easier for the AI to stay grounded in reality or in the context you provide.
Makes sense.
This technique is essential for things like generating long-form content, doing multi-stage data processing, complex research projects. Really, any kind of multi-step problem solving where the final output needs to be a synthesis of many smaller parts.
And this disciplined approach, breaking things down, it reinforces that idea we talked about earlier. Your prompt is your product.
Yes, it does.
The source argues pretty strongly against that common reaction people have. If the AI isn't working well, they immediately think, oh, I need a better model. I need GPT-5 or whatever's next.
Right. And the reality is, much more often, the bottleneck isn't the raw capability of the model. It's the instructions. It's the clarity, the structure, the design of the prompts, and the workflow it's being asked to follow.
So a well-designed prompt doesn't just ask for something.
Yeah.
It actually shapes how the AI behaves.
Exactly. It leverages the AI's existing knowledge and abilities, but directs them in a very targeted way. It effectively turns a general-purpose AI model into a specialized tool that's tailored for your specific need at that moment.
They had a good customer support example for this, didn't they?
They did. A vague prompt like, help me with customer support queries, gives the AI almost no direction. It might chat back, but it won't follow any specific procedure.
Right.
But compare that to a well-crafted prompt that acts like a mini job description and training manual combined. You are a customer support agent. You specialize in troubleshooting software login issues for our sauce company. Your persona needs to be patient and very clear. Okay, a user has reported they cannot log in. First step, ask them to confirm their username and what device they're using. Second step, give them step-by-step instructions for resetting their password and include this specific link. Third step, if those steps don't work, ask for their account-associated email address so you can escalate the issue to a human agent and tell them the expected response time is X hours.
Wow, that's incredibly specific.
Totally different, right? The prompt defines the role, support agent, the domain, login issues, the persona, patient, clear, and a precise multi-step procedure with conditional logic built in.
The underlying AI model could be exactly the same in both cases.
Could be identical. But the utility, the value it provides in that scenario, is entirely determined by that detailed prompt. Your prompt literally creates the product or the service that the AI agent delivers in that context.
This focus on instruction design, it naturally leads to other core principles for getting better performance. One seems really basic but critical. Specificity beats vagueness. Every time.
It sounds obvious, but it's so easy to forget when you're quickly typing a prompt. Vague input leads to vague output. If you just ask, summarize this report, who knows what you'll get back? It might be a general overview that completely misses the point for why you need the summary.
Whereas a specific prompt?
A specific prompt guides the AI. Like, summarize this quarterly financial report. The audience is a potential investor who knows nothing about our industry. I need you to focus specifically on the key performance indicators, KPIs, the year-over-year growth figures, any major challenges the report outlines, and future opportunities it mentions. And present the summary as an executive brief, no longer than 500 words.
Okay, that leaves much less room for error or irrelevance.
Exactly. You give it clear boundaries, clear focus areas. It ensures the AI filters the information and highlights precisely what matters for that specific audience and purpose. Specificity helps the AI find the signal you care about within all the noise. And that applies to everything, whether you're writing marketing copy or analyzing dense technical documents.
Okay, so specificity is key. What about consistency? If you need the AI to always use a certain style or format things in a particular way.
For that, the source introduces a really powerful technique called few-shot prompting.
Few-shot prompting. Okay, what's that?
It basically means you include examples of the kind of input and output you want directly within your prompt. You show the AI what good looks like rather than just trying to describe it in abstract terms.
Like giving it a template or some completed samples.
Exactly. Think of it like giving the AI a few examples of the finished work product you expect it to create.
The guide had an example for this, converting product descriptions into ad copy.
That's the one. If you just say, write ad copy for this product, the style could be all over the place. But with few-shot prompting, you provide examples first.
How would that look?
Like this. Here's an example of what I want. Product description. Lightweight ergonomic mouse with customizable buttons and silent clicks. Ad copy. Click in comfort. Work in silence. Get your ergonomic, customizable mouse today. Okay, now using that style, convert this description. Doable waterproof backpack with padded laptop sleeve and multiple compartments.
Ah, I see. By showing it the first input-output pair, the AI learns the pattern.
Exactly. It learns the transformation you want, the kind of tone-punchy, benefit-focused, in this case, the typical length. So when you give it the second description, it's much, much more likely to generate ad copy that follows the pattern set by that first example.
That seems incredibly useful for, well, lots of things. Maintaining a consistent brand voice.
Definitely. Creating templated responses for customer service FAQs. Generating structured data outputs that always follow the same format.
And the source made a point about not needing tons of examples, right?
Yes, that's a key insight they call the power of few examples. You often don't need a massive data set like you would for fine-tuning a model. Sometimes just a handful, the source suggests, maybe around 10 really well-chosen examples, can be remarkably effective at getting the AI to follow the pattern you want.
Okay, so we have techniques for clarity, structure, consistency. But what about accuracy? That's still a huge concern with AI, right? The tendency to just make stuff up. Hallucinations.
It's a major challenge, absolutely, especially when you need factual answers based on information the AI wasn't necessarily trained on, like internal company data or very recent events.
So how do we combat that?
The source introduces retrieval-augmented generation, or RAG, as a really fundamental solution here.
RAG. Okay, retrieval-augmented generation. What's the core idea?
The core idea is to stop the AI from having to rely solely on its internal, potentially outdated or incomplete knowledge. Instead, you give it access to relevant, trusted information from outside its training data before it generates the answer.
How does that work in practice? Let's say I ask about my company's specific policy on, I don't know, parental leave. That policy definitely wasn't in the AI's public training data.
Right. So a standard prompt might lead to a generic answer, or worse, a completely made-up policy based on guesswork.
Yeah.
With RAG, the system would first retrieve the relevant section from your designated trusted source, in this case, your company's actual HR policy documents may be stored internally.
Okay.
That specific relevant passage is then provided as context to the AI model, along with your original question. Tell me about our parental leave policy.
Ah, so you're feeding it the facts first.
Exactly. And crucially, the AI is then instructed to generate its answer based only on the information provided in that context. This grounds the AI's response in verifiable facts pulled directly from your trusted data source. It drastically reduces the risk of hallucination.
So it becomes less of a know-it-all and more of a research assistant.
That's a great way to think about it. It finds the relevant facts first and then synthesizes them into an answer for you. It's effectively citing its source material, even if implicitly.
And this gets really powerful when you connect RAG to a private knowledge base, right? Your own company documents.
Absolutely. That's one of the most impactful applications. You curate and upload your own specific documents. Could be proprietary research findings, internal standard operating procedures, detailed product manuals, confidential project briefs, historical sales figures, anything.
And the RAG system indexes all that.
Yes. It creates a searchable private library from your documents. Then your AI agent can answer questions, summarize information, or perform analysis based only on the verified information contained within that private knowledge base.
The source had an example using an employee handbook.
Yeah. Instead of asking a generic question like, how do I request vacation leave? And hoping the AI gets it right.
You use RA and prompt something like,
Using the information found in the attached employee handbook document, outline the specific step-by-step process for requesting vacation leave at our company, making sure to mention any required forms.
and because the RH system pulls the relevant section from your actual handbook.
The AI's answer will reflect your company's specific policies, forms, and procedures, not generic stuff from the web. This is absolutely essential for domains like legal, medical, finance, engineering, anywhere where accuracy based on internal, verified, often proprietary data is non-negotiable.
This seems directly relevant to decision intelligence systems.
It's foundational. Leveraging RGA to query private knowledge bases is key for building reliable decision intelligence, especially in complex environments like those modeled by Twin Labs. AI agents in these systems must be able to access and reason over proprietary business data, things like equipment maintenance logs, supply chain details, sensor readings to provide accurate recommendations or trigger the right actions within the context of that digital twin. You can't have them guessing.
The guide also briefly explains how AG works under the hood, conceptually at least.
Yeah, it helps to have a basic picture. Essentially, it's about letting the model tap into external facts before it generates text.
How does it find the right facts?
Typically, the system first takes your large documents and breaks them down into smaller, manageable chunks of text.
Okay.
These chunks are then indexed, often using fancy techniques like vector embeddings that capture the meaning of the text, not just keywords. This makes them really fast to search semantically.
So when I ask a question,
The system searches across all those indexed chunks to find the ones whose meaning is most relevant to your question. It retrieves those relevant passages.
and feeds them to the AI.
Right. Those retrieved chunks are bundled together and passed to the AI model as part of the prompt's context, along with your original question. And the final, crucial step is instructing the AI model. Generate your answer, but base it only on the facts contained within these passages I just gave you.
Got it. So it bridges the AI's ability to generate fluent language with the need for factual accuracy from specific data sources.
That's the core idea. It's a really important bridge.
Okay, moving beyond individual prompts and techniques like RH, the source really stresses thinking about prompt engineering more systematically. It's not just a collection of tricks.
No, not at all. Effective prompting is presented as a systematic design process. They even compare it to user experience, UX design, but focused on how we interact with and instruct the AI.
So what does a systematic approach look like? The guide mentions a system prompt.
Yeah, a well-structured system prompt is like setting the stage for the AI before you even give it a specific task. It's the foundation for getting predictable and reliable behavior.
What goes into it?
Typically, it includes things like clearly defining the AI's role or persona. You are an expert financial analyst specializing in tech stocks. Setting specific constraints on its output. Respond only using data from the provided quarterly report. Maintain a formal and objective tone. Limit your response to 300 words. And maybe providing explicit instructions or examples for the desired output format or the process it should follow.
So by setting up these parameters beforehand,
You establish a baseline for the AI's behavior. It helps ensure you get consistent, high-quality outputs across multiple interactions as long as they fall within that defined role and set of constraints. It's about building reliability right into the AI's core operational setup.
but even with the best system prompt, things can still go wrong, right? AI can still give weird or incorrect answers sometimes.
Absolutely. Like any complex system, they're not perfect.
Yeah.
Which is why the source talks about the importance of debugging prompts, much like a software developer would debug code.
How do you debug a prompt?
The key principle is tracing the AI's reasoning process. Let's say you prompt an AI, calculate the projected ROI for our Q3 marketing campaign budget of $50,000. And the number it gives back just feels off.
Good.
The debugging step isn't just changing the $50,000 number, it's modifying the prompt to get visibility into how it arrived at the answer.
Like asking it to show its work again.
Exactly. You change the prompt to something like, calculate the projected ROI for the Q3 marketing budget of $50,000. Important. First, show your calculations step by step. Clearly list the formula you are using and the specific values you are plugging into that formula. Then, provide the final ROI figure.
So you force it to expose its internal logic?
Right. By demanding that intermediate step, the step-by-step calculation, you can examine its process. Did it misunderstand one of the inputs? Did it use the wrong formula entirely? Did it make a math error?
And once you see the specific error,
You can refine the original prompt with more clarity or add specific constraints to prevent that particular type of error next time. It's diagnostic prompting, finding the root cause of the failure so you can fix it in the instructions.
this ties into another really practical point the source makes, especially for businesses or regular users. For most people, getting better AI results means focusing on refining prompts and workflows.
Not trying to fine-tune the underlying AI models themselves.
Right, because model fine-tuning sounds really complex.
It is. It's technically challenging, it requires huge amounts of carefully prepared data, and it's computationally very expensive. It's usually something only large organizations or specialized teams would undertake.
Whereas refining prompts is something anyone can do.
Pretty much. And it's incredibly effective. The source shows how even small, specific tweaks to a prompt can make a massive difference in the quality and relevance of the output.
They used writing a tweet as an example again, didn't they?
Yeah. Generic prompt. Write a tweet about our new product launch. You'll get something bland.
Hi.
Optimize prompt, applying these principles. Draft a tweet, maximum of 280 characters. Announce the launch of our new cloud-based productivity app. Use a playful and energetic tone. Include relevant emojis, and make sure there's a clear call to action linking to our website. Insert link here.
That's much more directed.
Completely. adding the character limit, defining the tone, specifying style elements like emojis requiring the call to action. It transforms a generic request into instructions for creating a genuinely useful piece of marketing content tailored to the platform and the goal.
And this is where those few-shot examples come in handy again, too.
Definitely. The source revisits the power of few examples here. Adding just a few examples of past tweets that performed well can quickly teach the AI the desired style and content for your brand, often much faster and cheaper than trying to technically fine-tune the model itself.
Okay, so all these techniques, structured prompts, chain of thought, RAG, few-shot examples, debugging, they all start to build towards this idea of truly agentic AI, right? Systems that do more than just answer one question at a time.
Exactly. Agentic AI is where these components come together to create systems that can handle more sophisticated problem solving, operating in a kind of continuous loop.
A loop? What kind of loop?
The source describes a core operational cycle that mimics how humans often tackle tasks: plan, execute or act, observe, and reflect.
Plan, execute, observe, reflect. Okay, break that down.
So when faced with a complex goal, the agent doesn't just jump in. First, it might plan its approach. This could involve breaking the main goal down into smaller sub-goals or outlining the steps it needs to take.
Makes sense.
Then, it executes or acts on that plan. This is where it performs the necessary actions, maybe generating some text, running a calculation, calling an API to get data, using a software tool.
Okay, it performs the step. Then what?
Then, it observes the results of its action. It looks at the output it generated or the data it received back. It checks for errors, compares the result against the immediate goal of that step.
And finally, reflect.
Yes, it reflects on its performance or the observations it just made. Did the action achieve the desired outcome? Were there unexpected issues? Does the plan need to be adjusted based on the results? This reflection might lead to correcting errors or refining its approach for the next step, or even future tasks.
So this plan, execute, observe, reflect loop. That's what allows an AI to handle more complex multi-step tasks autonomously.
That's the fundamental idea, yes. The source uses analyzing complex sales data as an example.
How'd that work?
The agent might first plan by identifying which reports it needs to generate and what data sources it needs to query. Then it executes by writing and running the code to pull the data and create initial summary tables or charts. It observes those outputs, maybe checking for inconsistencies, missing data points, or outliers. And finally, it reflects. Does this analysis fully address the original request? Did I miss any key factors? Is the summary clear? Based on that reflection, it might decide to revise its analysis, generate additional charts, or rerun parts of the process.
That reflect step seems particularly crucial for building AI that can actually get better over time.
It is. Reflection for self-improvement, as the source calls it, is about building a self-critique mechanism right into the agent's workflow.
How do you do that?
After the AI generates something or completes a step, you explicitly prompt it to evaluate its own work based on criteria you define. The example they use is drafting a press release. The first prompt tells the AI to write the draft. But then, the next prompt isn't just edit this. It's something like, review the draft press release you just wrote. Evaluate it specifically against these criteria. Is it clear? Is it exciting? Is it concise? Is it relevant to our target audience? Based on your own review against these points, suggest specific improvements to make it more impactful.
So you're turning the AI into its own critic using your standards.
Exactly. You make it apply that layer of self-correction and refinement based on the criteria you care about. This can significantly improve the quality of the final output and cut down on the amount of basic editing humans need to do. It's like asking your junior teammate to review their work against a checklist before they hand it over.
Now, for really big, complex projects, this source talks about going beyond even a single agent operating in that loop. It introduces multi-agent systems.
Right. This is for tasks that are just too large or involve too many different kinds of expertise for one single AI agent, no matter how sophisticated. The idea is to design a system where multiple specialized AI agents collaborate. Each one handles a specific part of the overall workflow.
Like how a human team works, different roles.
Exactly like that. The classic example the source gives is like having a research team. You have a researcher agent whose job is just to find relevant information, maybe scouring databases, internal documents via RA or the web.
Okay.
Then you have a writer agent. It takes the information gathered by the researcher and drafts the actual content. Maybe it's a report, an article, marketing copy, whatever.
And then maybe an editor.
Precisely. An editor agent reviews the draft from the writer. It checks for grammar, style consistency, coherence, maybe even factual accuracy, perhaps using RAG again to cross-reference claims against the source material found by the researcher.
So this division of labor, it lets you optimize each agent for its specific task.
Yes, you can tailor the prompts, the constraints, maybe even use different underlying AI models if one is better at research and another is better at creative writing. It improves efficiency, makes the system more scalable, and generally leads to higher quality outcomes for really complex projects. You're breaking the problem down not just into steps, but into specialized roles.
This sounds like a really important pattern for building complex business solutions.
It really is, especially in areas like the advanced digital twin platforms developed by Twin Labs. These systems are inherently complex and often benefit from multi-agent architectures. You might have one agent dedicated to constantly monitoring real-time data streaming from sensors in the physical asset. Another agent might specialize in running complex predictive maintenance simulations based on that data. A third agent could then analyze the simulation results and generate optimization recommendations. And maybe a fourth agent handles communication, alerting human operators to critical issues, or even triggering automated adjustments back in the physical system via the twin. It's a very effective way to manage the different functions and data flows within a sophisticated digital twin environment.
And even within these multi-agent systems, the source comes back to the importance of preventing hallucinations, right? Especially when information gets passed between agents.
Absolutely. The fundamental principle doesn't change. You have to ground the AI in sufficient context. Vague instructions are still dangerous.
So Agent A can't just tell Agent B, tell me about Project X.
Not safely, no. Agent B might just invent details about Project X if it doesn't have explicit information. The correct approach, tying back to ARG principles, is for Agent A to provide the context. Agent B, please refer to the attached Project X brief document. Summarize the key objectives, timeline, and assign team members listed in that brief.
Always providing the source material.
Yes. By referencing a specific provided source, you ensure the information being passed and processed is grounded in facts you control, not AI guesswork.
Makes sense. And alongside accuracy, as these agents get more capable, especially if taking actions, safety becomes a bigger concern. The source mentions guardrails.
Yes, guardrails for safety are critical. One interesting technique discussed is using smaller, more specialized AI models to act as checkers or verifiers for the outputs of larger, more powerful, but maybe less predictable general models.
Like a safety check.
Kind of. For instance, you could have a big creative model like GPT-4 draft a complex clause for a legal contract. But then, before that clause is used, a smaller AI model one, trained very specifically and only on the legal compliance rules for your industry reviews that clause, just to check for potential compliance risks or violations.
Ah, so it's a specialist review. The big model generates, the small model validates against specific rules.
Exactly. It's like having your main expert write something, but then having a dedicated compliance officer review it specifically for risks before it goes out the door. This layered approach adds a crucial layer of reliability, especially when errors could have major consequences: financial, legal, safety, operational.
This discussion about safety and validation naturally leads into what seems like the next major evolution the source points to. AI that doesn't just talk or analyze, but actually takes action.
This is where the agent concept really earns its name. Agency implies the ability to act, to influence the world.
What kind of actions are we talking about?
The source lists several examples. Modern AI agents, through integrations, can call application programming interfaces, APIs. This lets them fetch real-time data from other services, like current stock prices, weather forecasts, or inventory levels.
Okay.
They can interact with code repositories, like GitHub, to maybe submit pull requests for code changes they've generated.
Wow.
They can send emails, schedule meetings, update records in the CRM, basically interact with many of the software tools we use every day through APIs and integrations.
So AI is moving beyond being just a language processor.
Fundamentally, it's becoming a system capable of interacting with other digital systems, and through those systems, influencing the real world. It means AI agents can be embedded directly into business processes to truly automate tasks, dynamically gather information as needed, or trigger entire workflows.
This sounds exactly like the goal of the developing AI agent service offered by Twin Labs.
It aligns perfectly. Those agents aren't just built to sit there and generate reports about a digital twin. They're designed to take action based on the insights derived from the twin.
Like what kind of action?
For example, automatically generating a maintenance work order in the company's ERP system when a predictive model running on the twin's data indicates a high probability of equipment failure. Or maybe adjusting operational parameters within a simulation environment based on optimization calculations. Or sending a very specific alert notification to the right team member when a complex pattern of events is detected by the twin. The action capability is key.
So pulling all these threads together, the prompting techniques, RE, the agentic loop, multi-agent systems, action capabilities, the source sums up the components needed for the best AI workflows, right?
Yes, it emphasizes that building truly capable AI agents isn't about just one magic bullet. It's about designing a system that integrates several key elements effectively.
And those elements are.
They list four main ones. First, effective neighboring, prompting the clear, structured instructions we've spent so much time discussing. Second, memory the agent needs mechanisms to maintain context over longer interactions and access relevant historical information or knowledge bases like those used in our RAG. Third, tools giving the agent access to external capabilities beyond just language, like web search, calculators, code execution environments, or the ability to call specific APIs. And fourth, feedback loops incorporating ways for the agent to learn and improve, whether through self-reflection, perceiving explicit human feedback, or analyzing the results of its actions.
So consciously designing systems with those four components, prompting, memory, tools, and feedback, that's how you build robust, reliable, and genuinely useful AI agents.
That's the formula presented, yes. It's about architecting the whole system, not just writing individual prompts in isolation.
Okay, let's try to summarize the key takeaways from this whole deep dive. We've covered a huge amount about moving from just talking to AI to actually building powerful agents. What are the absolute must-remember points?
I think the core lessons that come through again and again in the source are these. First, really internalize that power shift. For most practical applications right now, getting better at instructing AI through smart prompting is often more impactful than just waiting for the next slightly better model. Your skill in prompting matters hugely.
Okay, prompting is paramount.
Second, actively use techniques designed to improve the AI's reasoning. Chain of thought, making it explain its steps. The explain first, then answer method for judgment tasks. These force more reliable outputs.
Slow it down to make it smarter.
Third, be relentless about structure, specificity, and using examples in your prompts. Vague instructions get vague, often useless results. Define the role, constraints, format, and provide few-shot examples whenever possible.
Specificity, structure, examples. Got it.
Fourth, embrace RGAG, especially with your own private data. It's the key defense against hallucinations and the way to ensure accuracy when dealing with internal or domain-specific information. Crucial for trust.
Use RAG for factual grounding.
And finally, think bigger than single prompts. Start designing agentic systems. Use that plan, execute, observe, reflect loop. Consider multi-agent approaches for complex tasks. Build systems, not just prompts.
Right, build systems. That leads to the main concluding thought from the source, what they called the final insight. Can you remind us of that?
Yeah, it's a really powerful and practical piece of advice. Master your current model.
Master your current model.
The point is, don't get caught up solely in the hype cycle of constantly chasing the newest, biggest, shiniest AI model, assuming it will magically solve all your problems. While new models are exciting, the incremental gains might be small for your specific use case.
So instead of just waiting for the next big thing,
Invest your time and effort now in mastering the principles we've talked about. Get really good at prompt engineering. Learn how to structure effective workflows. Figure out how to integrate RAG with your data. Design agentic behaviors for the models you already have access to.
because a well-guided current model beats a poorly guided future model.
Often, yes. A moderately capable AI model, guided by expert prompting and well-designed workflows, will consistently deliver better, more reliable results for your specific needs than a state-of-the-art model that's just given vague or sloppy instructions. Focus on your skill, not just the tool.
And that's directly applicable to creating real business value, isn't it? Especially in complex areas like the work Twin Labs does.
Absolutely. Applying these techniques, structuring prompts meticulously, using RAID to ground decisions and private business data from a digital twin, designing multi-agent systems to handle the complexity, building in reflection, and the ability to take action. This is precisely how you move from raw AI potential to building reliable, trustworthy AI agents that actually help businesses make smarter, faster, data-driven decisions. It's how you create targeted, actionable intelligence.
It really shifts the focus. So maybe a final thought for our listeners to chew on, building on all this.
Well, if prompting clear, precise communication with AI is becoming the key skill to unlock computing power, rather than just complex coding, What does that mean for the future? What skills become most valuable in the workforce? How do businesses need to adapt their training, their team structures? And maybe even more profoundly, how do we design our core business processes when we have intelligent agents capable of understanding complex, nuanced instructions and then taking independent, reasoned action based on them? What does work look like then?
Lots to think about there. Definitely a paradigm shift in progress. Thank you for joining us today. Visit the Twin Labs website for more business insights.